In SolidWorks 2014, we've seen the Conic functionality introduced into the Fillet tool. Let's switch to SolidWorks. So prior to 2014, we could apply constant radius and variable radius fillets, but these were limited in use due to the sharp changes in curvature that were generated. We did have the option to apply curvature continuous fillets, which did produce smooth results, but they were limited to a constant radius. So we'll have a look at the Conic fillet in 2014. We're just going to roll back to before the finger hole cutout and then delete this top edge fillet, which I'm going to replace with a Conic fillet. So we'll launch the fillet tool and I'll just apply a fillet to the top edge. Within the fillet property manager, we now have a profile drop down where we can define a circular fillet or define a conic row or conic radius value to define our fillet. If we have a look at conic row values and just zoom in on the model, you'll see that as I decrease the size of the conic row value, the fillet almost flatten out, so similar to a chamfer almost. If I increase the size of the row value, you can see we generate a much sharper fillet. The conic row value is the angle at which a plane passes through a cone. If we set this to 0.4142, this actually gives us a circular fillet. Perhaps a little easier to understand is the conic radius fillet. This allows us to define the minimum radius of curvature of our fillet. So where the conic radius value is the same as the fillet radius value, we have a circular fillet. Again, if I start to decrease that number, we start to get a sharp fillet. If we increase it, we almost get, again, like a chamfer. Now, where this tool is really powerful is our ability to use it with the variable fillet. So we're just going to set up the variable fillet here. We're going to add in some control points, like so. Now, as a start, I'm going to set all of these control points to a 10mm radius with the 10mm conic radius. We're going to take the top center value and increase that from 10 to 15 for the radius while maintaining the 10mm conic. And down the bottom, we'll reduce the conic radius value to 5mm both sides. So that should start to sharpen up in that region. Okay, so a really interesting result there that we get, which would have been difficult to achieve before without our normal fillet tools. We'd have probably had to have used surfacing. We also find here that the conic functionality is also supported within the face fillet. So if we create a face fillet between that surface and that surface there, we'll just reduce our radius down to 5 and we'll leave the conic radius at 10. So this is going to be useful for people that do surfacing where they don't necessarily have two intersecting faces that they want to create the fillet between. Now if we just launch the fillet tool again, just something else that I want to draw your attention to. When we're defining our fillet size, we can now define it with a radial value or by a chord width value, which just allows us to define the dimension between the start of the fillet and the end of the fillet, as indicated by the symbol next to it. If we roll to the end, we're going to apply some conic fillets to the neck. So we'll launch the fillet tool again and we'll do a face fillet and we'll go between that face and that face there. In this instance, I'm going to specify a 5mm radial fillet with a 1mm conic radius. So that almost gives us a draft-like effect in that region. We'll just finish this off with a constant size fillet on that face and we'll just change the conic radius value again to 1mm so it sharpens in that region. So again, some really nice results that we wouldn't have been able to achieve without probably using the surfacing tools before. If we just switch back to the PowerPoint, we'll just summarize what we've seen here. So we now have conic fillets where we can define a conic row or conic radius value. We can produce variable conic fillets And within the face fillet UI, we now can define chord width, and we now have the option to specify conic fillets. We'll now switch to Ed for assembly delighters.